Let's begin with this first prompt from sample ACT exam. It reads, Shannon walked 1 2/3 miles on Wednesday and 2 3/5 miles on Thursday. What was the total distance in miles Shannon walked during these 2 days? Let's look at the choices. They're all in what's called mixed notation. Why mixed notation? Because you have a whole number part and you have a fraction part. So let's look at choice A, for example. That choice reads 3 5/8. It's called a mixed fraction. Why? Well, because it has the whole number part. This is a whole number, or an integer. And then this is a proper fraction. Proper in the sense that the numerator here, the 5, is smaller than the denominator here, the 8. We'll talk about improper fractions in a second. Okay, so in order to answer this prompt, what do we need to do? Well, with the TI-83, TI-84, you're going to find that it's extremely simple to solve. But it's still worth going over fractions for a minute. So what we need to do here clearly is add 1 2/3 of a mile and 2 3/5 miles. We're going to add these two together because that's what the prompt wants. It wants to know how many total miles Shannon walked in those 2 days. So it would be 1 2/3 plus 2 3/5. Now, because these are improper mixed fractions, please note something very important about mixed fractions. 1 2/3 means 1 plus 2/3. We're adding to that 2 plus 3/5, 2 plus 3/5. And I mentioned this because you know that in math, typically, when you have, say, 2x like this, you don't see a mathematical operation between the 2 and the x, so this means multiply, right? Well, in mixed fractions, we have an exception to that rule. You see the 1 and the 2/3 here, no mathematical operation in between, so really you wouldn't be crazy to think that it means multiply, but it doesn't. It's one of those exceptions to the mathematical language that we have to be careful with. It simply means add. In the case of mixed fractions, you need to know that. Otherwise, again, you wouldn't be crazy for thinking that it meant multiplication. So mixed fractions like this really stands for 1 plus 2/3. A mixed fraction like this one, 2 3/5, really stands for 2 plus 3/5. Okay, so now to solve. Well, if we didn't have a TI-83, TI-84, what we would need to do is, that's relatively simple. We could add the whole number parts, the 1 with the 2, so that's equal to 3. But then we have to add the fraction parts, the 2/3 and the 3/5. So to add 2/3 plus 3/5, we would need to first make sure that we have both fractions with the same denominator, because you can't add these fractions the way they're written. This is in terms of thirds, this is in terms of fifths, and so they're not compatible. So what we need to do is we need to convert. Well, the lowest common multiple of these would be 15. 3 can go into 15 and 5 as well. So if we multiply 2/3 times 5 over 5, we get 10/15. So 2/3 is equivalent to 10/15. And then plus, well, 3/5, we also have to change it in terms of 15ths. So we achieve that by multiplying 5 times 3. So that means the numerator will have to be multiplied times 3 as well. So we get 3 times 3 is 9. That's how you multiply fractions straight across. 5 times 3 is 15. And now we can do 10 plus 9, which is 19, and the 15th is the denominator, which stays. It's in terms of what we're adding. So this would be the answer, 3 plus 19 over 15. But there's a problem. This is what's called an improper fraction. I mentioned that earlier. Improper fractions are those where the numerator is bigger than the denominator, is larger in size. And so what we need to do is we need to change that. Well, 19/15 would be the same as 15 over 15 plus, well, 15 plus 4 is 19, so plus 4/15. Think about it. 4 plus 15 is 19/15. Well, 15 over 15 is really equal to 1. So that gives us 1 plus 4 over 15. Now we had 3 already waiting for us, and 3 plus 1 plus 4/15 would be equal to 4 plus 4/15. In other words, 4 4/15, which is choice C, the correct answer. Complicated, huh? You really...
To add fractions using the TI for problem 1, so we need to add 1 2/3 plus 2 3/5. There's several ways in which we can do that. So on the one hand, we can go to the math key right here, press math, and then we move over to frac for fractions, and we select that second option, which means unit decimal as in fraction form. So this is a mixed format, the mixed fraction format. So if we press 2, it's going to allow us to enter a value for a mixed fraction like that. So if we're adding 1 2/3, 1 for the whole number part, and then using the arrow keys we move to the numerator, and that's where we would enter the 2, and then using the arrow key move down to the 3. Using the arrow key we get out of the fraction. We're going to be adding plus, and then 2 3/5, so we again key in math, frac for fractions, and then that second option, so we get another mixed fraction that we can fill in there. So it's 2 3/5, so it's 2 for the whole part. Using the arrows we navigate 3/5, and we can just press enter at this point. We don't need to get away from there, and if we press enter we see that the answer is 64/15. Now the problem is that this is an improper fraction because the numerator is bigger, greater than the denominator, and the choices shown on the ACT exam are in mixed number format. So how do we go from this to a mixed number format? A couple of ways we can do that. If we go to the math key right here, and we select fraction again, and then look at this fourth option here. It says from a fraction, numerator, denominator, switch to a mixed fraction format. And it's U and then ND for numerator, denominator. So if we select the 4, what the calculator is doing, it's automatically assuming that this previous answer, that's why the answer is shown, we wanted to switch it to the unit with numerator, denominator. In other words, to a mixed number format. And there you go. That's the correct answer for that first prompt. Now, I said there were a couple of options here. What's that second option? Well, if we go back to the original expression that we wrote, we can navigate with the arrow keys and move all the way up there. You can see how it's selected. I press enter. It's going to give me a new entry line with that same expression copied here. So if I press enter, I'll see the answer is 64/15 again. And assuming that I want a mixed number, how do I do that? Well, the second option is to go to mode, press mode, and then scroll down to where it says fraction type. Notice that right now it's selected the numerator denominator format, but we have the option of selecting the unit numerator denominator, in other words, a mixed number format. So if I go there to fraction type and select that option, press enter, clear, I'm back here, and then I press enter for the answer again. Look how instead of displaying the answer in improper format and numerator denominator, it's showing it as a mixed number. So those are the two choices. Now just be careful, because if say you have that format selected in the mode option here, and some of the prompts require you to just leave it as a regular numerator denominator type format, you're gonna have to come back here, change that setting, select the numerator denominator format, and then you're good to go. Okay?
Let's go over this second prompt. You're supposed to find for x to the third power times 3xy squared times 2xy squared, and express it as one of these 5 choices shown here. So this is an algebra problem. So you have 4x cubed, and you're multiplying times 3xy squared. multiplying times 2xy squared. And this confuses a lot of students, and it's sad because it's really simple. Multiplying terms like these or expressions like these is very straightforward. Just think about the following. Let's say that you have 2 times 5. 2 times 5. Okay, there you go. Now 2 times 5 is of course equal to 10, right? Let's do now 2 times x. Okay, this is 2 times x, and we write it as 2x. Now, powers are really a way to simplify writing for us. Let's say that we have 2 times x times x. 2 times x times x. Well, because we have a couple of x's here multiplying, we can use power notation to simplify our writing here. So this is what it stands for, and then I can just write 2x squared. Let's say that we had 5x, x, x. So that would be 5 times x times x times x. Well, this time we have 3 x's multiplying, so we can use power notation and simplify that at x to the 3rd power. Now 5 times x cubed is of course 5x cubed. And remember, these are all equivalent. It's just that this is a lot easier to use than, something as crazy as this. You have a lot of x's there, it's a waste of time. And math really is always trying to find ways of simplifying our writing and avoiding having to write so many symbols and letters, etc. Because otherwise we could make more mistakes and it could get very confusing very quickly. Okay, so why did I go over that? Because if you now go back to this prompt and we read it again, and it simply wants us to know the product of 4x cubed times 3xy squared times 2xy squared. Well, even though it's going to seem silly to you, let's see what happens if we expand this. 4x cubed is really 4xxx. You have to agree to that because we just went over it. Now we're multiplying times 3xy squared, so we could write that as 3xyy. And then we're multiplying times 2xy squared, which is 2xyy. You should agree that these expanded forms, yes, are exactly the same to their forms in which the prompt is written. Now, if we have all of these things multiplying here, I don't really need the dot or the multiplication symbol. I can just put them all together. 4xxx, 3xyy, 2xyy. Now I can rearrange. Why can I do that? Because there's a property of math that says, for example, if I have 2 times 5, which we know is equal to 10, I can change the order into 5 times 2, and that'll still be equal to 10. So I can move things, shuffle things around when everything is multiplying, as is the case here. In other words, the numbers, I'll put them at the front of the expression. So if I have a 4 times, let's bring the 3 to the front part here, and let's bring the 2 as well. So 4 times 3 times 2. Then I can just put the x's together. X, x, x. These are accounted for. I have another one here. Let me bring that there. And then I have another one there. Let me write it. And then y's, I have 1, 2, 3, 4. So 1, 2, 3, 4. And this answer is actually correct. But if we look at the choices here, none of them are expressed in this format, of course. So we need to simplify. Well, 4 times 3 is 12, and 12 times 2 is 24. So there you go. 24 is going to be the coefficient part, the number part. And if we look at the choices, right away we know that f is wrong and g is wrong. It eliminates those two choices. Now we look at the variables. Well, we have how many x's? 1, 2, 3, 4, 5. So that's x to the 5th power. Now looking at the choices, that eliminates h. So we're left with j and k. Well, the y part, the y variables, we have 4 of them. So that is written as y to the 4th. Our final answer, 24, x to the 5th, y to the 4th power, which is, of course, choice J, right here. Now, we don't need to go through all of this to solve this prompt. I do that to explain how algebra works and, some of the properties involved. But really, what you should know, or what you could use when you face a prompt like this, is that whenever you have a continuous multiplication expression like this one, where everything is multiplying, all of the elements are multiplying, you can shuffle so that you bring the 4, the 3, and the 2 to the front multiplying, and 4 times 3 is 12 times 2 is 24. And then when you have variables with different powers multiplying, you add the powers of the same variables. In other words, you have x cubed times x to the first power times x to the first power. Well, you add their powers. So it would be 3 plus 1 plus 1, so that's 5. So that's x to the fifth power, because you have 5 of them multiplying. And then as to the y's, you have y squared and y squared. So you again add their powers because these variables are multiplying each other. So that gives you y to the 2 plus 2, which is to the fourth power. And that would be the same answer we obtained using the other method. So this is a shortcut method, of course. This assumes that you know those properties. But you can think about the other method when applying those properties, and just to make sure that you understand why those properties work. Math should never be about memorizing. It should really be about understanding where. Okay, let's go over this third prompt. Mr. Wilk is a high school math teacher whose salary is $33,660 for this school year, which has 180 days. In Mr. Wilk's school district, substitute teachers are paid $85 per day. If Mr. Wilk takes a day off without pay and the substitute teacher is paid to teach his classes, how much less does the school district pay in salary by paying a substitute teacher instead of Mr. Wilk for that day? And then you see some choices, and clearly they're all dollar amounts. So let's go over this and see how it should be solved. First of all, we know that Mr. Wilk, right here, is a math teacher, and his salary is $33,660 for the entire year. So let's write that. $33,660 for the year. Now, the year has 180 days. Doesn't mean that a year has actually 180 days. We know it has 365 and change. It just means that in terms of how much a teacher is paid, they're considering 180 days of work. Okay, now substitute teachers are paid $85 per day. And typically, substitute teachers are paid less than a permanent teacher. And so that's where the difference comes from. Now, if Mr. Wilk takes a day off without pay, that means maybe he had something personal to do. He's not going to be paid because he's taking that time off. How much is the school district going to pay less because they're going to hire a sub teacher for that day instead of Mr. Wilk? Well, to know this, we really don't have a way of solving it the way with these figures, because we know how much a sub earns in a day, but we don't know how much Mr. Wilk earns in a day. We know how much he earns in a year. But we know that this salary for the year considers 180 days of work. So clearly, if we divide $33,660 in a year by 180 days, we will be able to know how much Mr. Wilk earns per day. So dividing, and I'm going to show you in a minute how to use the TI to do this, dividing 33,660 by 180 gives us $187. So this is what Mr. Wilk earns per day. Now you can see that Mr. Wilk, as a full-time math teacher, earns more than a substitute teacher, which again is typically the way things work, because subs sometimes do not have to meet all the requirements that a full-time math teacher needs to meet, and because the math teacher has a permanent position, etc. So these are annual contracts, yearly contracts. So for numerous reasons, this is what typically happens. Now, if Mr. Wilk is earning $187 on a daily basis, based on his yearly contract over here, now we have something to compare. 187 for Mr. Wilk, 85 for subs. So if we want to know how much less, and that's key, how much less the district's going to pay, well, the district is going to pay 85. But if Mr. Wilk had worked that day, it would have paid 187. So if we subtract 187 minus 85, we'll be able to know how much money the school district saved. So 187 minus 85 is equal to 102. And that's the amount of money saved by the school district. It's important always to read the questions because you need to understand what exactly they're asking for. And because it says here, how much less does the school district pay because it hired a sub instead of paying for Mr. Wilk, then this is the operation that you would need to do. And therefore, choice C is the correct answer. Now let's see how this is solved using the TI.
For problem 2, Mr. Wilk, as we know, earns $33,660, so that's his annual salary, divided by 180 days. So we divide by 180. And we get the salary, the daily income of $187. Then we know that the sub is paid $85 a day. So to find the final answer, we would subtract from 187 the cost of hiring a sub for that day. And this is how much money the district pays less because Mr. Wilk took the day off without pay and they needed to hire a sub to cover for him.
Let's go over this fourth problem. The student has earned the following scores on 4 100-point tests this marking period: 63, 72, 88, and 91. What score must the student earn on the fifth and final 100-point test of the marking period to earn an average test grade of 80 for the 5 tests? And then you have some choices here. The last one says the student cannot earn an average of 80, which could be valid. We just need to do the math and see if that's really the correct choice. Okay, so this student has already earned a 63, and then a 72, then an 88, and finally a 91. That's 1, 2, 3, 4 tests. Now, there's a 5th test, which is going to be the final test for that marking period. So this entire marking period is going to have 5 tests. And what we need to know is, again, based on 100-point tests, so they're all equal, we need to know how much the student needs to earn over here so that the average is equal to 80. Well, the first thing you need to know is how to figure out the average of a set of values. To find the average, of course, we add the values and then divide by the number of values that we used. So in this case, say we have 63, 72, 88, 91. We have 4 values. We could find the average for these 4, so we would add these 4 numbers and divide by 4. But that's not really what we need to do here, because they want us to know, considering this 5th test, for the entire marking period, we want the average to be equal to 80. So we have this missing test here that the student is yet to take. And the question is, would the student still be able to get an average of 80 for these 5 tests, considering that he still is yet to take this one? So how do we solve this prompt? Well, very simple. If the average is found by adding all of the values, and this is a question mark, we'll call this x. Now we know that these scores plus x, which is the unknown value, divided by how many values are we using? 1, 2, 3, 4, 5. So divided by 5 should be equal to 80. And this is an equation that we can now solve. So to solve, we need to know, obviously, a little bit of math here. We need to know that because we have these values adding, and on the numerator, the 63, the 72, the 88, the 91, and the x, that we can actually add these numbers, the 63 plus 72 plus 88 plus 91. And adding those numbers, we see that the answer is, and I'm going to show you on the TI how to do that, but right now I'm just going to work this on the side. So 63 plus 72 plus 88 plus 91, and that's equal to 314. So we get 314 plus x divided by 5 is equal to 80. All I did was I added these numbers, which I actually have. Now, to solve this equation, we have to look at the left side of the equation and see that we have the 5 that is dividing the numerator, the 314 plus x. Because it's dividing, we really want to get rid of that because we want to isolate the x, the variable. In other words, we want to send the 5 to the other side multiplying because that's the opposite of what it's doing on the left side, which is dividing. Or we simply multiply both sides by 5. That's another way of looking at it. If we multiply both sides by 5, then we're essentially canceling these 5's here, and that leaves us with 314 plus x is equal to 80 times 5, which is 400. And now to solve for x, if we have a 314 on the left side, adding with the x, well, how do we get rid of this 314? Well, we can simply subtract 314 from both sides of the equation. And that means that 314 plus x minus 314, the 314's cancel, leaving us with x. And that leaves us with 400 minus 314. And of course, if we do 400 minus 314, we get an answer of 86. In other words, this student would have to score an 86 on that last test to average 80 for that marking period. Now, if this seems complicated to you, there's a way around this. You can actually, when you read the prompt and you look at the choices, you can trick this a little bit. If you're afraid of, setting up the equation and trying to solve it, and you think that you're going to spend too much time doing that, what you can do is you can look at the choices and use them. And, if you're fast enough, it'll actually won't be that bad. In other words, you would need to know that adding 63 plus 72 plus 88 plus 91 plus that x value, the unknown score, and then dividing everything by 5 would be equal to 80. You still need to know this. But here's what you can do instead. Well, you add all of these numbers first, which we already did, and we found that the answer to that was 314. So you're essentially left with 314 plus x divided by 5 is equal to 80. If you're a little bit unsure as to how to solve this, it's not all lost. Think about it. You have the first choice 79, the second one 86, the third one 89, and the fourth one is 94. You leave the last one until the very end. So if 79 is correct, plugging in 79 for x here, adding and dividing by 5, should be equal to 80 if that's going to be the right choice. So if we do 314 on the calculator plus 79, it gives us I did this correctly. If we do 314 plus 79, we get an answer of 393. And 393 divided by 5 is clearly not equal to 80. It's equal to 78.6. So 79 is not the right choice. We then change that and use 86 and see what happens. So we do 314 plus 86, and that gives us 400. And then when we divide 400 by 5, we get 80, which is the average we wanted. So we know that 86 is a correct choice. And so G, 86 is correct. If 86 had not worked, then you would move on to H, and then you would move on to J. And then if none of those values work, then you would obviously pick a K. So it's a way of working around this problem. If you're a little bit unsure as to how to solve an equation like this one, know that when you take the ACT, you can be very creative as to how you approach these prompts. And one of the tricks is to use the answers provided to see if you can figure the problem out. You would still, again, need to know how to find the average of a set of values and know that this is what you're after. So, there's still that, but at the end of the day,
To find the average, so what we had to do was to add 63, 72, 88, and 91, and that gave us the 314. Now 314 plus x divided by 5 is equal to 80, which is the average we want. So we had to multiply 80 times 5, giving us 400. So that gave us the expression 314 plus x is equal to 400. So solving for x, we would subtract 314 to both sides, leading to the computation 400 minus 314, which is 86. X is equal to 86. That is the grade we were looking for.